Welcome everyone to Cloud Computing and Big Data again. Today we have a practical lecture 5.1 that complements the more theoretical view on MapReduce and Apache Hadoop that we had in lecture 5. And today we really want to see a little bit and explore the AWS service environment, and we'll play around a little bit with the Elastic MapReduce service, but also get an impression how security works and things like that. So before we go basically in this material of the lecture, just let us rewind a little bit what we had the last time when we thought about the MapReduce approach, which we know is essentially nothing really new. It is rather something which is built on traditional computer sciences, where divide and conquer was invented many, many decades ago, of breaking a big problem into smaller chunks. And of course, today, this is by large what people also think in getting big data problems basically small. Of course, you partition the problem into smaller areas, and then you have basically, or smaller volumes, for instance. And then you basically have different workers working separately. We call that nicely independently parallel in order to get to some form of result. So you see here the processors are there. We have the partitioning, we have the combine, and this is really something not really new. What is new on top of this is really the idea of having a framework, which really does essentially one key aspect more that we have learned last time. And this is this interesting magic insight, which is called group shuffle sorting by the framework. And it is related to the key value pairs that we alluded to, where, for instance, in the word count that we explored theoretical the last time, the key was a word, and all what you do is basically as a value is say +1, +1, +1 in the map phase. And then in the reduce phase, you always basically then all these occurrences will be combined where the key equals is, the same. And the beauty of this is that you just provide the map and also the reducer task, and we will see how that materializes when we have the demo today. But of course, it's also interesting to see that we have essentially here a framework that does a lot of things automatically in the back. And we talked about the motivations for this, which was hide the underlying computing complexity that is actually growing stronger and stronger, more difficult. Then also the storage complexity. We have more types of storage, different file systems. And then, of course, on top of it, we learned also in lecture 4 already that data centers always have lots of faults. So we want to have a system which is essentially fault tolerant by design when there are errors in hardware. And what we see here is essentially a big in the middle framework setup, which is built on top of these ecosystem from MapReduce and HDFS. So this is really HDFS, which is really a complementary setup of having a computing engine largely fueled by parallel task execution through MapReduce, and then basically an environment of reliable data storage. And this data storage today is also sometimes exchanged in different types of data storage, but the idea remains the same, that you have lots of different other services around it and build on the MapReduce paradigm. We have a metadata catalog, for instance. We already talked about the new SQL HBase database, and on top of it, you maybe deploy Mahout for machine learning, for movie rental or something like this. We already used Hive for SQL structured query languages in the assignment. So this is really an interesting setup and really in a very lively open source community that has been developed out of this and is basically now, as you see on the right-hand side, available in all the different cloud environments you have out there. It's available in the Google Cloud as the data proc services. We already played around with HD Insight, and there you see there's also Spark, Kafka, HBase. And also, as we will explore today, Amazon has a counterpart of this called largely the Elastic MapReduce stack, which is not only MapReduce, it's really, again, the idea of combining all of these Apache projects, Hive, and so on in one setup. That doesn't mean you have to use always them, basically, together. But of course, it's an aspect that really plays nicely together. But what we also will explore today when we create some instances, that this is a little bit loaded because there are lots of different versions of these open source projects. And now if you would be an administrator in one of the companies in your system, you all have to make this in sync with each other, right? So some versions of Mahout doesn't work with this particular version of MapReduce. So the stack that you see on the advantage side is of course very nicely, uniquely trimmed and fits together. On the downside, you have to get the versions right. And of course, this is where you then can consider cloud computing, because the administrators would have less cost, to use essentially than the clouds, then maybe, spending a hell of a lot of time to make all of these versions right. So this is of course something what you could consider before, having always administrators working a long time to streamline these. You maybe just, go to the cloud where there's always basically such an ecosystem existing. Another fact, because it's also about big data in the course, is that we learned in lecture 4 that we really have a file system as HDFS that is ready for big data. And in general, what we want to achieve a little bit is this data locality principle. So instead of shipping data again and again away, we create already data nodes which are with some computing attached, and we just send the task more or less to the data node, right? And so with this, we break up the big data already in smaller chunks and blocks and tell a name node about it. So there's one very special node that knows where all the blocks reside. And of course, this is one important aspect of it. And another aspect, which is then adding to the fault tolerance, to the resiliency, is a replication strategy. So we can really say that we want to deploy here different settings of one block really, and then duplicate it 2, 3, 4 times, depending on the value for the company or on the availability, how often you want to compute, how often you really want to do something with it. All right, so I think this is largely what we discussed the last time, and we will now go into some practical examples in the cloud and so on. And you see, it's a practical topic. We will have first an understanding what the Amazon Web Services cloud environment is. We will see that it has a very broad service portfolio. It has a very interesting pay-per-use approach. Of course, here in the university, we will engage in the AWS Educate program, and all of you basically should have gotten already an email for an invitation because it's related to future assignments. And we will explore a little bit the Elastic MapReduce service in a, let's say, more overview, where we initially in the first part think about connections to security, connections to the Elastic Compute Cloud service as well. So they are different services, but they are all in one way or another, of course, interconnected or make use of each other. So we will learn this in the first part, and then having some interesting application examples just alongside to tell you also that, of course, big companies that started maybe as small startups, right, like Airbnb or Spotify, are now really heavily using AWS services every day in production. And in the end, a little bit of a machine learning examples. Now, when we then go into the second part of today, we will try to understand MapReduce more. So once we know already a bit about the AWS cloud environment and basically then starting to deploy different services here, we will also explore then what the dependency is with the security pairs that we established in the first part of the lecture, but then also think about security limitations, roles limitations that you basically then also partly solve in the assignment. Then basically we have this word count as a very simple hello world, and there are, let's say, lots of ways how you could make use of it. And you will explore that also when you execute it yourself in one of the assignments. And with this, you really understand then better the MapReduce functionality and the built-in aggregations, which are also quite nice today, and different ways how you actually can execute something in the cloud. Admittedly, a very simple example, but given the time that we have, of course, it's not possible to cover all the different services, but parts of your assignment will, so you get some hands-on experience in this. And of course, then we again point out that this is all part of a very larger MapReduce ecosystem of applications. And in this sense, it's really important for us to think about it. Right, so thinking about more practically now, the Amazon Web Services cloud environment, what is it? It has, lots of different services, and now we narrow it down, right, with this MapReduce paradigm. They say from all of these services which are there basically in this Amazon world, we have some goal, and the goal is to do something with our MapReduce framework. So this is also the way how you would use a cloud. You would have a certain meaning, a certain idea. It's probably not that you will say we just use Amazon and then think, okay, what do they have? So there should be good motivation when you be in business, when you come out of this course and tell your boss, I want to use a cloud. And he will immediately ask, is it necessary? Because it costs, right? So this is something to think about. For us, it's now very clear. We assume we have a MapReduce problem. And we said already we want to do the word count with MapReduce. Can the cloud help us? And we already said it's a very nice paradigm, adding now much more with this open source implementation Hadoop to basically the divide and conquer strategy. But still, we have to think ourselves, can we have a problem that we can divide? I did some earlier examples already in one of the earlier lectures where weather forecast is highly interactive between all the different worker nodes. They have to exchange lots of physical properties from one tile affect the other. Or the ocean simulation that we do in the complementary HPC course. It goes from one tile another, propagating waves. So when it's lots of interactions on a very, let's say, high frequency, then this is basically not the framework you go for. Meaning you also have to think about that the data and the problem should really, fit to what we want to achieve. Now think about word counting is so trivial that we think that can be run in parallel, nicely parallel, independent parallel. So we can basically say the words of one document really doesn't affect the words of the other document. All I'm interested in the end, in the result, is the overall number of words, right? And want to have this information for me prepared. Now, let's look a little bit in the AWS Cloud Service portfolio. And this is, of course, a really important thing to think about, that there are so many different services around. So it's amazing, really, what you really have here. And with this, of course, you have lots of different challenges you have to basically think about. And the one is, of course, finding yourself the way through it. It's a jungle of services. It's really powerful, but also an overwhelming much, especially in a university setup, right, where we want to have, let's say, an overview. In Amazon, you can imagine, as a strong company in this field, there are always innovations, almost daily, what you can do better now, what you can do in a better fashion, what you can combine with other services. We will come to this, of course, then in lecture 8, lecture 9, lecture 10, when we talk about IAAS, PAAS, and so on, and SAAS, more on an interesting level where you're starting to combine all of this. Today, we really focus here on the elastic MapReduce. Of course, automatically, you would think it is a more computing paradigm, so we will touch also on the data, because computing without data doesn't make sense. Now, when we look in this approach of clouds, the first thing that comes to your mind when we recap a little bit our process that we had, the 7-step process that we also will have later here in the course today, we need some form of account, we need credits, we need something to work on. Of course, normally that means you have to go to the AWS services. You can, for instance, use the AWS free tier to subscribe. Still, they want to have your credit card already, because if you exhaust your resources in the free tier, they want to start charging you. And of course, that's a business model. And this is always there, and the free tier has a very elegant and attractive services actually that are very good to start from. Of course, once you have done this, you're a bit of hooked. Think about this when you go back to your company or wherever you work and want to introduce this, right? You start something, a dependency, you have maybe loaded up data into it, you basically do other things, and then suddenly you say it's all for free, they will start paying. So it's good to think a bit more strategically when you move to clouds. Where do you want to create an account? Now, for us here in the course, admittedly very simple. We will use the AWS Educate package, which is especially for the university. We are registered officially in this. So this is a benefit, of course, for us. And if you see what services are there supported, you see here essentially that you have the Elastic MapReduce as one of the supported services. And basically what you can consider is that for other types of services that will come in subsequent, basically assignments, we will always check if these services, of course, are currently there. There could be always changes in these lists. And but here, of course, we will check if things are actually running. Now, here's an example, and again, alluding to some practical aspects. When I now go to the Educate starter account and to the website, and filling this a little bit with live, let's make a short demo on this. So you would get here an AWS account, and basically you can see that you really sign in to this AWS Educate. For you will get an invitation to a certain class I will alluding to in a moment. So if anyone did not get the invitation already, please, after the lecture, send me an email and tell me. And you see here, this is a space that is really organized for teaching. You have some interesting different ideas of doing, classrooms, and they have materials that you can link in. You see here featured contents. You have some interesting additional resources that we could do. And it's a very attractive way of basically teaching this. And of course, let's not forget, and this you see here, we get $50 per student for free. Now, let's say if you are an own researcher and don't need me, you can still be, let's say, your own student. You also get $50. So you can always, let's say, propagate this to your friends that are not part of this course, and they still can try AWS Educate as part of the University of Iceland. That works. However, here in the classroom, it's more organized, and of course, take away the message that when you go outside the educational sector, this is not going to work, right? You need to really be essentially in an educational setup. They will check it. The class that we have here was under review, so people have really looked at before we actually can use it. And now the interesting thing is the free tier will be also there for you, of course, when you go out of an educational sector, but also the free tier has not every of the services. And one interesting example is that the Elastic MapReduce we're going to use today is actually not part of the free tier. And that is for me a little bit, let's say, an interesting setup, because many people use these services, right? And so they probably would be liking to use them in the free tier as well. So that's an interesting setup. But if you think twice about it, you could also say it's a business model, right? Because now everybody knows that many people use these, Apache products. So not giving them away for free is maybe another idea. So I'll leave that, in the room for you to think about it. I don't want to really judge on that, but the good news is we got approval for our classroom, so I go to our classroom. You will see every now and then when you use it, interesting, small hints that you just have to be informed, just like that, for instance, AWS has here a specific team that is doing essentially these classroom features. But also when it comes to some services, you will notice every now and then that we basically have their different, different ways of getting notified about privacy, about other things with your account happening. So when you are in the area from your class, you can pick them. You see you have also a starter account, you have a particular class, and if you take this class, you see some information about it. And this is of course very important for us because this is essentially what they call a workbench, right? And from this workbench, we will get to our AWS management console. So, and of course, it also gives you the overview about your remaining credits, right? So this is important, of course, to think about that we need the money to really use the services. And as I point out also many times in the lecture and in the last assignment, please use the account again responsibly, meaning every time you stop working, shut down, terminate everything that's there. There's no problem of recreating it again. Also in the future assignments, you get basically a lot of scripts for walkthrough. Essentially, that prevents you from having lost all your credits, because when the services will run in the cloud that we're going to create now, they still will be charged partly. So you could be running out of credits. Important is also to use this AWS console here. So this will be now the next feature which I will talk about, and which is essentially the heart of AWS when you log into it. So you see here lots of different services in this console, and lots of tutorials, interesting things about different topics like machine learning, big data that usually goes often together, storage, database, more computer science topics. So also, let's say, very trivial aspects than just building a web app or building some, let's say, websites even. So there's lots of options what you have here in the AWS management console. Of course, here on the right, it's interesting to have your different regions. We will talk about this, and your assignment will also cover parts of this. And of course, information about you, who of the users you are, and so forth. Get some notifications here, by the way, as well. So the interesting thing is, and now let's go a bit back to the slides that we move on here, and that you see essentially all what I demonstrate here is also partly on the slides, right? Here's a process about your student invitation email you should have got. The idea how to use it is that you use a link that is assigned to this and then basically provide passwords and of course accept the invitation. And once it is accepted, you essentially can do the same thing that I just actually showed you. You can go to this classroom. Now, when we see now the how it looks like, the kind of workbench we have seen, essentially, it is looking very similar to each other, even if you're an educator and you're not. But please make sure to go this route to your classroom and then use this AWS console, of course, then given your own account. And this brings us really to the central access of these services and functionalities, right? We will see there's a very broad service portfolio that you have there. And just let me explore a little bit with you interactively as a demo what I mean with this. So you have seen all services, maybe not yet, but this is huge. Right, you see now lots of Amazon services, and they all perfectly make sense. They have containers, which we will talk at the end of our course. They have lots of new machine learning. Actually, we also will touch base on some of them, like SageMaker and so forth. They have bare metal computing mostly, or things which are related to virtualization, right? They have storage, databases. You would actually now thinking about, they have almost everything. So for analytics, there are several aspects. So you see they have a very broad service portfolio. And if you stick these things together, which we will still learn in lecture 8, lecture 9, and so on in future lectures, how to stick them together to achieve a goal, we today start a little bit with this. So when you do basically a search, and for our reasons here, we want to look a little bit in the EC2 world. It's a kind of elastic compute service. And what it is, I show better in slides. So essentially, when you search for this, and you can, let's say, pick it, that's very clear. And then we basically connect directly to something what we already talked in one of the earlier lectures, right? So when we think about EC2, we mean, okay, it's actually depending on the size of the computing. It's either very expensive, and we used Spark, for instance, and said we need high memory or memory optimized. Then you go here and pay the price for it, with $13 or $26. And on the other hand, we have sometimes interesting new non-volatile memory. So it all costs, and you always have to be aware of this, particularly in the light of the fact that it is essentially an underlying service of many other services, right? In the end, you use these instances for other services, for instance, like Hadoop and Spark that we will explore with Elastic MapReduce later. So this says that you not only buy the service, but also the underlying resources. That's why sometimes the resources get eaten up so quickly. And what I want to first start with as a demo here is to do a very important subject. We will come back to this also in lecture 8 in the assignments, of thinking a little bit how you basically can access these services and how they are secured. Essentially, we would see that we have a secure shell access with key pairs. We see essentially there a key which is broken into two parts, and we explore that a little bit now together. How it works is essentially that you have your private key, you generate this in the cloud, but you download a private key, and this private key stays on your laptop. Whatever you do, it will never leave your system. It's considered to be, of course, your private secret. However, the public key is then given to the cloud. So the public key is open. It is known by the EC2 instances that you're going to create. And the way then how the security works with this public-private key pair is that every time you access essentially the instance, you use the SSH access, for instance. We will talk about this, and it's basically, you will also learn in the assignment how to get then really with it to log in of a remote service. And this is interesting because it's by far everywhere applied today. You see this not only in this cloud, of course, it's in all other clouds. And of course, admittedly, it's a very low-level way of assessing the service. We see also in the AWS Management Console later, you can completely all the time also use kind of the browser-based way to access the services. But of course, if you now think about automated scriptings, administrators, they prefer these command lines, and they would probably go into these systems with SSH, just to provide an example. Another good point is the keys that we're going to create now are for regions. So it's not that you basically can take one from another region and move it, and use it then in a completely different region. So that is really something you should take into account also when you do your assignment. We need SSH clients for it. MobiXterm is the one that I recommend. It's open source to be used, but there's also PuTTY that you can use. And of course, Mac and Unix users usually have also an integrated client already in their Unix derivations that they have with their OS. So essentially, you can very quickly then access an EC2 instance. So when we do this now, we go to this page that you have already seen in the demo here. We go to the EC2 page that we have seen here, where we can launch instance for the Amazon EC2, but we want to create some key pairs. So let's see and let's explore what that is. We create key pairs, and essentially we would have then, Morris key pair 3, just to provide an example. And we create this key pair. Of course, there are lots of options which type of keys you actually use and so forth. But you see here also, I can now actually save my private key in this store and will download it. And that should remain on my laptop. And every time I want to use my SSH client that you will use also in the assignment, things like MobiXterm here, they will definitively wants you to point in a session of SSH then very quickly to your private key, right? So that this will be a very important part. You see here, use the private key, and then you can actually pick your PPK that you have there. But showing SSH is essentially not the key topic of our course. So we want to do more services in the cloud. We have now this interesting key pair, and it is good to know that it's firstly limited by the region. But of course, also it's good to know that it's now known everywhere in this region, meaning whatever service it is that requires key pairs, you can already, choose from them. And this is, of course, a very nice feature. So let us explore a little bit what I mean by this when we go to the EC2 page, for instance. We want to launch here a specific instance, also something what you will do in your assignment, especially in deep learning. You see we have here some deep learning instances that we can select, for instance. And once you do this, you have different, let's say, ones you can choose from. And add storage to different elements. It's not so important for you, but of course, what I wanted to say is you always have security, right? And this is something to think about. Here you see we have to really, particularly for the EC2, configure that this SSH key is actually allowed. It has a very specific port range and so forth. So this is something what we have to add here as a rule, and is important to consider when you launch these services. So this is just an example, so don't worry about this. Let us come a little bit now back to the slides, essentially. So all what I just did is essentially also on the slides, so I don't repeat it here. You would have the mobile X term as an example, but you can of course use also different ones. Here you see essentially an example where I think it's kind of motivating for us also to engage then in the second part of the lecture when we really see these systems are really used. So first of all, there's an AWS marketplace. There's a collection of really community-centered images, software, tools. It is a rich, very rich store essentially of lots of different elements. So let's go quickly to this marketplace homepage. And here you have lots of categories where you can already, all related of course to the AWS services, can see what is interesting for me as a company, data and analytics, what can I do there, and what can I maybe also contribute, because of course not only taking things from there, there's also the possibility to get involved and share your things with others. You see here different interesting things of data science. You see clustering, for instance, and you get more information and basically then can link to others that offer you something in it. So here's a specific Databricks platform that is optimized for this. And you can basically have these same contexts which are related to AWS together explored with a very specific analytics platform. But this is just one example. If you go to other examples, Hadoop, Spark, you will find lots of others that provide you add-in values, different container solutions in R for statistical computing, maybe already prepared for Hadoop, lots of different, let's say, tools. And this is a reason, and you have seen, I guess, when you come to the main page, how many there are. Yes, about 9,433 overall. So it's a quite lively community, lots of things to explore before you start off and doing the work yourself. So coming back to the slides, because the marketplace would be a complete teaching lecture usually to talk about this, just to give you some motivational hint here that, of course, Airbnb is a company known to all of you, quite strong today, but think about it, was scaling with becoming, a big company. It was a startup company in the beginning. So, and they use actually lots of EC2 instances for their kind of application problem. If you know a little bit about Airbnb, it's about, matching your requirements to essentially lots of housing opportunities where there's offerings and basically also people that want to sleep somewhere. And it's really using a lot of Elastic MapReduce, a service we will explore in the second part of the lecture today, in order to really, analyze the data on a daily basis. Another good example is that Spotify is using these services, especially in the terms of storage. So it has lots of licensed songs. So when you have a, let's say, membership fee in Spotify, which is actually not that expensive, you actually have access to a lot of music. And this instant access that you literally have is completely fueled. We are using the Amazon S3 service that we had also already in one of our earlier lectures. So you see it's really used, and this lecture is more a practical lecture thinking about MapReduce. So we will go to deeper parts of this when we have lecture 8, when we really try to understand the underlying concepts of clouds and how companies can use it to make an added value. Now with this, I think I have already talked from my parts that I wanted to present in the first part of the lecture. It was largely just setting up the infrastructure with the key pairs, understanding the AWS Management Console, which is your key access, and then of course think a little bit about security. And we'll come back to this part 2 after a short break.